Hey everyone, this is Dave Cooper and we are in Austin, Texas with the Housing Innovation Alliance, and right now we are sitting in Community First Village, and with me is Dmitri from Icon 3D Printing, right? So
yes, sir.
I love it. So Dmitri, I think which is really going to be fun about this conversation is we have some stuff in common. You were a military guy at one point, right?
That's right.
Well, always military, I should say. But you know, what you're doing is absolutely incredible, right, as a company and 3D printing. So I really want to walk through, you know, the life cycle of what your vision is as a company, the technology that you're implementing to build a beautiful structure as sitting behind us right here, and really where we're headed. So if you could just take a moment, why don't you give everybody your background and how you got to where you are?
Yeah, absolutely. So my name is Dmitri Julius. I'm the Vice President of Operations at Icon. For those of you who are not aware, Icon is a 3D printing technology company. We utilize robotics, advanced materials in our cementitious material, and all of our tech to basically make as big of a difference as we possibly can in a paradigm shift in the global housing crisis. So we're trying to scale large-scale robots so we can build as many houses as possible.
Yeah, I love it. So there's a lot of things that are going into this outside of just using concrete and 3D printing. There's the whole technology side that's happening with what you're doing to make the ease of application for builders that are out there and for the process to really use this efficiently and effectively. Is that accurate?
And that's you nailed it.
Yeah. So why don't we talk a little bit about what is the vision of Icon right now? You know, where you started and kind of where you're at right now.
Yeah, so Icon started approximately 2 years ago with the grand idea that housing as it existed today needed a paradigm shift. We were looking for ways to create innovation in such a way that allowed for us to scale houses more affordably, more resiliently, and more beautiful than they currently exist. And so the co-founders, Jason Ballard, our Chief Technology Officer, Alex LaRue, and our chairman, Evan Loomis, founded a company to do so. So we started with that seed round, got a $9 million seed round to build a prototype, and effectively partnered with New Story, which is a philanthropic organization that builds social housing all throughout the world, to go deliver a proof of concept, which was, to us, one of the most magnificent things we've been able to participate in, is the world's first 3D printed neighborhood. And from there, what we've realized is this technology has legs in all different segments of housing. So not just affordable housing or tiny houses. There's a real opportunity for us to make housing more affordable right down the market, middle of the market, and also to do some things on either side of the fringes. And so that's what we're looking to do, is to leverage this agnostic technology to build beautiful, resilient structures, regardless of what it is that you're trying to build.
Yeah, for sure. All right, so before we jump into everything here, why don't we talk about where we're sitting? Let's paint the picture of, you know, Community First Village, why, you know, Icon has a house here.
Absolutely. So Community First Village is right here in Austin, Texas, near and dear to our heart. The founding group with Alan Graham and his team have effectively built a master plan community for individuals who were experiencing homelessness or were home insecure, and have found literally a community here in the village. And so what they've done is partnered with a bunch of different builders. Icon is one of many, to create multiple different housing pods all throughout the space, and then fostered programming for community and building jobs and things of that nature to effectively create a space that's conducive for everybody to live as beautifully as they would like to. And so we're so incredibly proud to be a part of everything that's going on out
For
here.
sure. I mean, this place is awesome.
Yeah, it's really cool.
It is awesome. Hopefully, you know, you guys can send us some B-roll for this, because really I think the world needs to see what's happening here. It's an amazing thing that's going on.
Yeah, so I'm from Southern California, and living right here in Austin, Texas. Homelessness is something that you see kind of, it's unavoidable, and it's really sad that our brothers and sisters are experiencing this level of pain, and don't have places to live, to call home. And so to kind of see someone doing it well and seeing it work and have it be right in your backyard is inspiring, and makes us want to do better.
Yeah, 100%. Well, you guys are on the cutting edge of a lot of things, so this is just one of them, and I think it's going to translate very well, you know, to other communities, hopefully moving forward. So, all right, let's hop into this a little bit. Let's talk about it. Here I am. I'm a developer. You know, I want to maybe use your product. You know, I was on your site. It says you have, you know, vertically integrated technology. Talk me through what is the process to design and build something with a 3D printer.
Yeah, so one of the most interesting things about the way that houses get built now. So I worked at another startup called Treehouse that was founded by Jason Ballard with the concept that you can take bits and pieces of things about the housing experience and improve them. So my house was built without solar panels. I'd like to go ahead and bolt those on, or I'd really like to become more sustainable, so I can go purchase a water catchment system and bolt that on. And those incremental improvements, they help, and they create comfort, but it's not exactly a big enough step to really start to push the needle on what's possible. And so when you take a look at how houses are currently constructed, you've got your architect, maybe, and you've got your subcontractors, stoneworkers, stonemasons, roofers, all the different paint, insulation, all of those different things. And so you've got this coordinated effort that takes place between 5, 10, 15, 20, 25 people sometimes. And there's a lot of hair on that process. And everybody in the process cares a lot about their specific piece of the job. But because it's not delivered in such a succinct way, it creates friction. So if you're the builder or you're the home purchaser, you want a succinct process that you can kind of move sequentially through A, B, and C. It makes sense. And so our developers are thinking really hard about the pain points in that process and creating a streamlined way for individuals to say, this is what I want in a house, and this is how I get it. And so our platform is going to be vertically integrated to allow all the tools necessary for your architect, for your builder, for your structural engineer, and ultimately for your end user, that home buyer, or your master plan community kind of developer, to have all the information that they need in one place to allow for a really streamlined process that's pain-free. So you can go from concept to built structure in one location.
I think that's absolutely amazing to actually build, bring all of those people into one platform, because you're right. That is not traditionally how it's done. Traditionally, they're not even talking a lot of times when you have architects and builders. Developers a lot of time have their own architects.
Yeah, maybe you have that one kickoff meeting, and everybody's there one time, and then it's a series of change orders, and you sign this piece of paper, and you agree with this change, and it comes back to someone. So we're really trying to take the pain out of that. And as someone who's built a home, and someone who aspires to build many others, we would like that process to be as easy as possible for everyone involved.
That's amazing that you guys are able to do that and take it all the way from the front end to the back end. That's the technology, right? So you're all the way at the front end, whoever the consumer is, all the way to the end consumer through manufacturing in the middle. And I think those processes are becoming more and more prevalent of a need in our industry. In a big way. So all right, so here we designed a product. We're going through the system. Now let's build this product. Tell me, what is the process there? How many people does it take? How do you lay it all out to get going?
Yeah, so actually the house that's you're sitting in front of right now, we built this with a team of about 6 or 7, and this was a year and a half ago. Right now, today, we could build this same house with a team of 4. And so effectively, the Icon technology shows up. We pull up on a flatbed, 40-foot trailer, and we roll the Vulcan system off of that trailer. We bolt it to the existing foundation. We set up the magma or the material delivery system. We power it, and we add water, and so you get a water silo off to the side. And then we press play. And all of the preloaded designs for this unit will begin. We'll mix the concrete. It'll travel in our hose system to the foundation, and we will build this structure layer by layer until it's complete. And so it's as simple as understanding how to use the tablet in order to deliver a structure like the one that you're sitting in front of.
So Dmitri, why don't you tell me a little bit about this unit right here? What was the start to finish time on something like this?
Yeah, so the Community First Village Welcome Center that we're sitting in front of right now was about 24 hours of print time. So that's spread across a few days, obviously. We don't want to be working into the evening hours, keeping the rest of the community up, but about 24 hours in consecutive print for the wall system. And then the completely delivered structure was delivered in about a month's time.
Wow.
So that's roof, windows, MEP paint, etc.
Yeah. Well, let's get into the process. So you mentioned the Vulcan delivery system, right? That is the 3D printing system that you come and set up and actually does these, looks like about a 1-inch bead that it lays around the house.
Got a good eye.
Yeah. So I think, with that said, so you set it up, that system comes in, and then you mentioned it's like a mixing system that comes in that feeds the Vulcan, right? The magmas. Tell us a little bit about how that system works.
Yeah, so the material delivery system is actually the crown jewel, we think. It does all the calculations for the material weight, the amount of water that needs to get added, the viscosity of the material, all of those things. It kind of takes care of that and makes that an automated process. So you don't necessarily have to be a concrete guru or have a background in rheology. All you need to know is how to read the tablet and understand kind of what your parameters are. It can make some adjustments based on humidity and overall exterior temperature, but the goal of that material delivery system is to make the mixing process as simple as possible so we can boot, scoot, and boogie over here as far as the house is concerned.
Boot, scoot, and boogie. We are in Texas. I love that. One of my favorite songs, by the way. Hey, so, all right, so here we have the system. It's laying out the walls. How do you know when to lay headers? Walk somebody through that's really trying to understand how do I use this? How do my trades use this, right? That's looking at the system. How do I know when to put a header in for a door?
Yeah, that's absolutely how we've been thinking about the technology. For the first year and a half of its life, it only spent its time in our hands. And our developers are doing a fantastic job thinking about what the use case is for other individuals. And so we've built in kind of parameters around using the system that make it really easy to know when header placement or things of that nature are supposed to take place. So you'll actually get a physical screen readout. How many layers until your header placement, or how many layers until a door jamb needs to be placed, and things of that nature to ensure that you don't mess up your print. And it down to the "have you understood what I'm telling you" prompt with a smiley face on the screen, yes or no, or I need to pause, or I need further instruction on what's happening, and it'll actually give you those pop-ups. And so it is as simple as kind of understanding how to read the tablet and making your course adjustments from there.
Right. Now, I'm going to hit on something on this because this is so important, especially with the trade labor issues that we're having today. And I mean, this is technology that young people can learn and use. I mean, this is a whole nother job description, building a house with a tablet.
Absolutely. No, it's crazy to think. I think one of the things that we want all of the construction builders and the master plan developers to understand is we're designing this technology primarily for them as our end user. We want to create something that is simple enough to use. Think elegant and easy to use, like your iPhone. You don't necessarily need to know the back-end engineering on why that thing works. You just need to know that it works when you pick it up to use it. And so we want to make this accessible and user-friendly to the entire workforce that currently exists to create a seamless integration of the current built environment and the one that we're pushing towards.
Right. So the concrete. I saw a picture years ago on the first project that Icon did, and it did not look like this.
That's right.
I mean, it was amazing. So how far you've come, and you're developing this system, and the concrete's proprietary to the Magnum system. Is that correct?
Yeah. So the concrete is proprietary, but the great thing about how we use it is most of the materials can be locally sourced, no matter where you're at. So if you're hailing from Western PA or you live right here in Central Texas, the vast majority of the ingredients that are in that mix can be locally sourced. We have made a great deal of strides when it comes to the material science on the back end of making it strong enough to stand up on its own and rigid enough to take that next layer's worth of weight. And also the cure times are incredibly important because, as you know, concrete is a finicky beast, and it kind of likes the temperatures that we like. And so you get too hot and it starts to dry too fast, and you start to deal with cracking. You get too cold and you don't go through the proper cure cycle. And so it is finicky, but we love it, and we are actively working to make it work for us, not against us.
Yeah, and I think I saw it's 6,000 psi. Is that accurate?
6,000 psi. Yes,
yeah,
sir.
so 6,000 psi. So that means it's watertight.
That's right.
Right. I think anything over 5,000, if I know my concrete.
You're doing pretty good.
Yeah.
And so what you're going to get is a contiguous exterior envelope that's going to have a really hefty thermal mass.
Wow.
But then the capillary wicking is left to a minimum. Yes, sir.
I love it. I got a book, man. I'm ready. I'm ready for this. This is the coolest stuff ever. So, all right. So moving on. You mentioned working with developers and so forth moving forward. Let's talk about how this eases what they have to do and how this fits into that whole community.
Yeah, and so when you think about the primary drivers that are kind of limiting factors with development, right? You talked about the labor shortages that exist in all the major trade areas. You've got the cost of materials, right? We're all kind of dealing with that. And then you've got the regulatory bodies that kind of make things what they are in your area. And so city, state, local, municipality level, like trying to figure out a way to best build your homes that meet the standard in your area.
Right.
And so we feel that this technology, when put in the hands of developers, can work directly with the labor force that currently exists. So this is an additional trade that you can teach on top of the things that already exist. And so it's not limiting in any way with the current workforce that we have. It limits the cost of additional materials needed because it's concrete, readily accessible everywhere in the world. And then you've got cost, which we can drive down by continuing to be able to build multiple structures at one time with the exact same labor force and limiting the amount of dangerous exchanges that kind of take place on a job site. So if I can build it with less people, the same people, and faster with less materials, that's a winning proposition for developers and for builders and for trades folks because they can get out, and the more jobs they can get to, the more opportunity to make money. And so
and there's the economy of scale of moving the machine one house to another on these developments. So economically, can we talk about that a little bit? Like what are the economic values to this type of thing?
Yeah, so you nailed it. And this site is another example of such. And so this is one singular structure that we printed with a printer. But yes, less than 1,000 meters away, we've got another site, excuse me.
Yeah.
I'm going to say that one more time. So you really nailed it when it comes to thinking about the economies of scale here. So this is one singular structure that we printed with the Vulcan, but 1,000 meters away, we've got 6 structures that we printed with one Vulcan in one fell swoop. And so scaling really starts to make sense when you're thinking about, green space building, that you can, have a fleet of 1, 2, or 3 printers, and they can print multiple structures with that same set of crew that we were talking about. And that scale really starts to work in your favor when you start to think about building 10, 20, 30, 50, 100 buildings at a time. And that's really what we're chasing down.
Absolutely. I mean, you end up with the skilled labor force, and with the skilled labor force, you just have the efficiency getting better and better each time they do it.
That's absolutely right.
For the project, so I could see that. All right, so so scaling. Let's talk about scaling. Why don't you tell everybody, what you guys are doing now with NASA, right?
Yeah, very casual. NASA. Yeah, we've had the opportunity to work with some large DoD partners, NASA of which is the most current. They just announced in conjunction with us big architecture and search Project Olympus, where we're going to be building permanent structures on the moon for astronauts and future use cases. And so we believe that this technology isn't limited to just terrestrial building. Once we've figured this out, there are multiple efficiencies that can be gained both here and in extraterrestrial environments.
So what I think is really interesting is, I mean, you now have a scientific lab. Is that correct?
Yes, sir.
Working through some of these things, and Lunar Soil, right, is one of the things I was reading and they were talking about. And how do you take what you have and use another planet's ingredients, so to speak, to do this and be very efficient without having to take all that material with you? Is that what you're looking at?
Yeah, so I'm not a material scientist. I'm going to give you my real quick Bill Nye understanding of this. But effectively what you're dealing with is you've got a twofold problem. You can't bear the weight of the concrete into space. So traveling with the material becomes an issue. And so you have to use locally sourced material again.
Makes sense, right.
So you're using Highlands lunar dust. And then you have all of the atmospheric challenges there. So you've got lack of gravity and things of that nature. So effectively, you have to be able to gather that material, heat it to the point where it actually turns into a lava type material, and then place it at that heat so it cools and stays in that location, and then effectively build on top of that structure. And so that's absolutely what we're
in a zero gravity environment.
Yeah, in a zero gravity environment, we are looking to laser center that material, and that's going to be one of the more more of the coming years.
I mean, that's so huge. And the funny part was, doing a little bit of research, that's always been a vision for Icon, from what I was saying, like taking it to the next level, and that's really to the next level.
Oh, this is a dream come true, I know, for our CEO and for me, a kid that went to space camp out Cape Canaveral. Like I am ecstatic at the opportunity to work closely with NASA on this project.
Well, I love it. All right, here's what we're going to ask. We're going to wrap this up, but I really want to understand from Icon's, what do you see with housing over the next, 3, 5, 10 years, and how does 3D printing fit into that in your vision?
Well, sadly, what I think we're going to see in housing over the next 3 to 5 to 10 years is the same thing that we've been seeing over the course of the last 50 years, is housing becoming more and more inaccessible to individuals across the country. Whether that be, first-time home buyers, individuals in the middle market or at either end of the spectrum, what you're dealing with is fewer and fewer people that have access to the American dream, which effectively is the home.
Right.
And we believe that this technology has the opportunity to put home buying squarely in everyone's crosshairs and have the opportunity to purchase their home. And we believe we can do that with efficiencies that'll help us drive down not only the cost of housing, but also creates numerous different layouts that are conducive to the type of living and the type of thriving that we would like consumers to experience.
Yeah, well, I saw one of your mottos is affordable, attainable. Is that what it was, right? Affordable, sustainable, and available.
That's correct.
Affordable, sustainable, and
Yeah, we want to build
yeah.
resilient, sustainable, beautiful housing in every opportunity that we can, and we believe this technology is going to lead straight to that.
Well, you guys are off to a good start, so.
Well, we appreciate it, and thank you so much for taking the time. Yeah, is there anything else that
No, I mean, I think we covered everything. So listen, everyone, we're in Austin, Texas, and I am sitting with Dmitri Julius, and who is the VP of Operations at Icon 3D Printing, and they are going to space even. So this is a lot of fun. We are with the Housing Innovation Alliance, where we bring you innovative things all the time. I'm Dave Cooper. Thanks for watching.